Hello, everyone. My name is Brian. I work on Google Cloud, and we're going to talk about where should I run my code, deciding between all these pieces. So I'm curious, how many people here write code today? OK, lots of hands. This is what, maybe 80%? How many people keep systems running? Like, OK, another maybe 30, 40%. And how many people tell other people what to do, like coordinate work, that kind of thing? OK, another 20, 30%. So lots of people here do multiple things. Thank you for coming. And I think this will be useful to all of those roles. So developer, operations, managers, all together. So this question, where should I run my code? And the answer is, of course, it depends. And so this talk will talk about all the different ways that it depends. At Google Cloud, we have a lot of blue hexagons. You've seen a lot of blue hexagons today. We're going to talk mostly about these four. And going to kind of start from the bottom up. So Compute Engine are our virtual machines. Container Engine is hosted Kubernetes, so orchestration for containers. App Engine is our platform as a service. Give us code, we'll run it. And Cloud Functions are kind of that internet glue. You just give a function definition, and it runs. So I'm going to make a claim that you can use each of these things for many different things. There's overlapping things, but there's a sweet spot, kind of the best happy spot for each of these. And I claim that Compute Engine is an excellent fit for any existing system. So you've got a large complicated system that runs lots of different pieces. It's probably running on virtual machines or on like hardware today, and you can move that over pretty much directly. If you have a system that is containers first, like you've got all Docker images and you're set up good to go and you have a lot of those, you want to keep track of them, Container Engine, Kubernetes is going to be a really good fit for that. If your application is primarily web, HTTP request response, App Engine is an excellent fit. And if you're trying to respond to events, asynchronous events, and you just don't want to think about the rest, Cloud Functions is awesome. So this is the claim I'm going to make. And we're going to go, like I said, bottom up. So VMs, containers, PaaS, functions. And then actually answer the question, seriously, where should I run my code? And then we're going to have Eli from Lumapps come up and talk about their decision and how they decided between these before they existed. So start off with Compute Engine. And Compute Engine is our virtual machines. Infrastructure as a service. It is compute, network, disk. We have all sorts of specifics. The machines can get quite large. 96 CPUs, 8 GPUs, lots of RAM, lots of disk. And you can make a VM with each of these almost independent. So you can have a machine with very large memory and relatively small CPU, if that's what you need for your application. They start very quickly, about 30 seconds. And we have lots of base images already that you can use to use the operating system that you are most familiar with. And then you can make your own images from those. I wanted to talk about the disk a little bit. So these are virtual machines, right? We all know how virtual machines work. Except in the cloud, things can work a little differently. So the disk, for example, bigger disks are faster in the sense of more throughput. So if you're doing any kind of testing, like perf testing, to want to see what's going to be fast, is this fast enough for you? Larger disks are actually higher throughput because you're getting a slice of all of these different disks in the data center, and a bigger disk gives you a bigger slice. So you actually have more physical disks working for you the larger the disk is. So that's maybe not obvious. And it's more than just VMs. So we have an optimized OS that you can use to just run one container. So if you want to run a Docker image, you can boot up a VM that's set up for doing that. We have this system called managed instance groups. So instead of thinking about one computer, you can think about a pool of identical computers. And when you do that, each of them is created from the same template. And so you can make that pool bigger or smaller. And you just have a dial for I'd like more computers doing this processing or fewer. And that allows auto-scaling. So you can hook that up to traffic or CPU metrics and have it scale the pool via those. Or use that to spread it across multiple zones. So if one zone goes down, you still have the same number of computers running because it will scale up in another zone. And you can use it for rolling updates. If you have a new version of the template, you can actually drop one machine off, add another one, drop another one off, add another new one, and use that to kind of roll to a new version of your base image that you're using. And then our load balancer, when you use Compute Engine or Container Engine, App Engine all the way up, the load balancer is actually configuring Google's data centers. So you're using the same load balancer we use for YouTube and for Maps and the like. So you get to configure it and go. It's pretty fun. So when you're using this, you are thinking about your software. You're thinking about the operating system you want to run, how much memory, network, disk you need, and the networking rules, how the pieces talk to each other. All of that is things you need to consider. And it's the things you're used to thinking about in IT, right? And there's APIs for all of this. It is a particularly good fit when you have an existing system. You're kind of lift something up and shift it to another place. This container optimized VM, if you want to just run one image, one Docker image, it's very handy. If you need a very specific kernel or very specific operating system, you may have license requirements that push you, like you're only allowed to run, say, 4 CPUs, for the licensing in the same machine. So you can use that. It's handy for running databases, and if you need like very specific network protocols, we'll see some of the other options only run HTTP, HTTPS. Each of the VMs starts in about 30 seconds, so sets your kind of scaling. You can run thousands of VMs in 60 to in a minute to 2 minutes kind of time frame. And it's up to you to decide how you update your software, update your OS, security patches. All of that work is still in your world. You have direct control and responsibility for managing that. So demo. Too much talking. Let's go and try something out. So this, yay. This is Google Cloud Platform. I'm going to show you is this relatively new? You haven't done too much looking at the website? How many people? OK, maybe this won't be so exciting. But the secret to Google Cloud Platform is this hamburger button. Everything is in the hamburger button. That's where all of the different features of Google Cloud are. So, and we will look at Compute Engine. When I actually have some things set up for later demos, and we can create a new instance. Yay. I'm going to pick a nearby European data center. And we can, of course, choose from some kind of setup pre-configured size machines. Or, sorry, wrong link. Or click Customize. And we get a slider for how many CPU cores do you want, how much memory do you want. We can max them all the way up, but I have a specific size in mind. It's kind of what I think of as maybe the answer. So that's the machine we're going to build here. And you can also, this is where you would set if you wanted to run GPUs and the like. you can choose the base operating system. I'm just going to go ahead and use one of the pre-made Debian machines we have. But you can also kind of pick from this whole list of different images, including Windows, SUSE, Red Hat, and the like. So we'll hit create. When I hit create there, it's actually made an HTTP request off to the backend, and it's allocating a new part of a set of hardware somewhere. It's connecting this disk image to the machine, booting the machine up, and then if I had set it up to start to run my code once it comes up. So, oh, hey, good. In demo fashion, it finished quickly. And I just wanted to show you this button here. This is the SSH button. And what this does is, since I'm logged in to the web interface, I have already done an OAuth authentication. Google knows who I am. And it will push SSH keys to the instance so that we can log in over SSH. And you can do this from the command line or from the web. And it's a real computer. We can prove that it's a real computer because we have scrolling text. Thank you for laughing at that. But basically, you can SSH right from the web. So that's a really quick tour of Compute Engine. So why might you choose Compute Engine? Consistency. If you do a test with 10 VMs, next week you should see the same behavior, the same performance with 10 VMs. Or in another region, the same behavior. You can choose exactly the shape of VM, and this is really handy for existing systems. Instead of trying to optimize or get a bunch of different pieces of software to work on the same machine, because it happens to have 128 gigs of RAM, you can give one machine 32 and the other 96, and just keep them separate with exactly how much they need to be happy. I will guess that everyone in here has had a computer run out of disk and fail at some point in their life. You can actually resize disks that are attached to VMs and make them larger, and then update the partition, in most OSs, update all the way through the OS so it sees the additional space, and actually give it space while it's alive, which is fun. And then our billing is set up to be as easy as possible to reason about, to understand, automatically give you discounts when you use it over time, that sort of thing. We also move these VMs, like if we have planned updates to the hardware or the host operating systems, we'll actually move the VMs to another machine, and it's almost unnoticeable. Usually in the single-digit millisecond pause, all the network traffic makes it through, comes back up, it's actually on new hardware, and we continue on. And it's a really natural fit for many existing systems. So Compute Engine, it's awesome. And if you're using Container Engine or App Engine Flex, all of those are actually running. We use Compute Engine as the base for running these as well. So all of the benefits I talked about so far, you get in these other tools as well. So next, this is going to be we're going to keep going. Container Engine. More questions. How many people are using containers, Docker, something like that already? OK, that's maybe 40, 50% of the room. That's awesome. And I'm going to just assume everybody else is interested. And so we're all in. So the short version of containers, why? It solves the, well, it worked on my machine, why doesn't it work in production problem very nicely. It also gives you a nice isolation between different processes, so they can't hurt each other. So they have all their dependencies, and they're kind of insulated from each other. And this enables all sorts of good things that you're probably aware of. Once you decide you're all in on containers, then you can end up with hundreds or thousands of containers, and that's where Kubernetes comes in. And it is an open source orchestration system for managing lots of containers. It lets you treat a cluster of machines as one thing. And you say, run this for me, and the cluster figures out where to put it. And if one of them goes down, it figures out where to start a new one. So it keeps things set up the way you want it to be. It's open source. There's the owned by a foundation. Like just a few days ago, Docker announced that they're including Kubernetes in their distribution in the future. It is really worth looking at. OK, so when you're using Kubernetes, what do you think about? You're thinking about your application. And I like to, when you get into a meeting room with your colleagues, you've got a whiteboard, and you're drawing lines and boxes between the different parts of the system. And Kubernetes actually lets you reason about your system in a very similar level of abstraction. When you're making a config file, you say, this component, I want 5 of them running, and it uses this other piece by name. And Kubernetes figures out how to connect them to each other, how to do the networking. So you get to live at this kind of whiteboard level thinking and push the configuration down to the computers at that level of abstraction. So that's really powerful. Container Engine is Google Cloud's hosted version of Kubernetes. So we run the cluster for you, we upgrade, keep the nodes up to date, update to new versions of the host, and scale the size of the cluster for you up and down. It's a very good fit for any situation where you need to insulate yourself from the environment. So you want to run the same application, say, on your own machines, or in a cloud, in another cloud, in China, and you need it to work the same way. It's also very useful to have consistent behavior through dev, test, production, and basically get high utilization out of your systems because you can have more code running on them. It's a really good fit when you know you're going to use lots of containers, so you can take full advantage of them and the ephemeral nature. I'm going to say it's a good fit for, but this is also kind of a requirement of needing good team communication. So between your dev, your ops, and your security teams, because the code is deployed in these images, if you want to make a security fix to that code, you need to be in the same pipeline that the developers are using. Make the changes in the compatible way. So probably you want a continuous integration system of some kind of build system, and you want good communication between the different parts of your organization. It requires you to use containers. So it is only for containerized software. And if you need things like per-machine licensing, it can get a little challenging, and the like. So that's there. The quickie version, I'm going to skip. Now we'll do it. Of this. So this is the overall UI for Container Engine. Because this is a talk, this is kind of like a cooking show. I've prepared the cluster already. It's already running. And we click on this. There's some information about the cluster here, but the main thing I wanted to show you is down here, instance groups. It's actually using the managed instance groups of Compute Engine to set the size of the pool. So we're just using regular Compute Engine features to do that. There is a dashboard built into the open source Kubernetes tool. It looks like this. And I currently have nothing deployed behind this load balancer. So there's a public IP address here, and which I guess if everybody writes quickly, you could look at. And there's nothing running there right now. So we can quickly say kubectl run something named nginx based off an image, a Docker image, nginx. And this is a web server that's very commonly used. And that's already deployed. So if we take a look over here, we actually already have this thing called a deployment, a pod. I'm not going to go into names too much, but this pod is one process running nginx. And in fact, over here in this window, we're already seeing that network connection actually finished, and we got the default web serving page up. We can also scale. And then say we want to actually have, say, 12 of these. And by the time I get back over here to refresh, I didn't even catch it with some of them starting. They're actually all running up and going. So that's a really quick feel for Kubernetes. So we talked about these things. Basically, it's very useful to insulate you from the other infrastructure. It enables higher utilization so that you can, the more processes you have running, the higher percentage of the CPU you're using, the less money you're spending overall. And it is a really nice abstraction spot for many folks. OK, next up is App Engine. So App Engine is our platform as a service. It lets developers focus on the code they're writing, and then we handle the rest. I think we could say it was serverless early on. So App Engine has been around for 6-7 years now. Actually, started in 2008, so more. And the trade-off for App Engine has always been, if you write your app in this particular way, then give us the code, and we'll scale it up and down from 0 traffic to millions of requests per second. And we can make that happen. Just recently, we've announced and released the App Engine flexible environment, which takes the good stuff from App Engine and lets you run any Docker image and have that managed by App Engine. So you can take and run whatever language you want to use, any specific C libraries you need, these things that were kind of limitations in the previous version of App Engine, and you can run them. And it also means you can kind of take advantage of the containerization you've been doing in other places. So pretty much, if it runs in a Docker container, you can run it on App Engine Flex. When you're using App Engine, you're thinking about the code that you've written in Python or Go, whatever language you're using, the HTTP requests and responses, and the version of your code. And that's about it. There's no servers that you need to worry about. You can focus directly on your business needs. As I said before, it's a really good fit. It's meant for serving websites. Websites or HTTP APIs, anything that's HTTP-based. Scales very well to high traffic. The standard version, we have runtimes for several languages, but you cannot add your own kind of binary extensions to it. And then the Flex version, basically anything you can do in Docker, you can do there. Today, it's not the best fit for sites that go down to almost no traffic, because Flex has a minimum of 2 VMs. So you end up paying for 2 VMs under the covers all the time. Whereas standard will scale down to 0 and pay nothing if there's no traffic. So a quickie demo of App Engine. So this is the App Engine dashboard for a site that I have that was made by a colleague, Justin Beckwith, and it serves up an image of fruit. It's the whole website. But there are multiple versions of this website, because some people like different fruit, and we've argued about this a little bit. We did some user research to figure out what the most popular fruit is. Let's do some right now. How many people here like durian? Actually, this is I'm not even sure that's an English word, much less translates over. Let's go ahead and switch the site, because we know durian is a very popular fruit. We're going to actually migrate all of the traffic from this site to a new version of the website that serves up a different fruit. And if I refresh the page, does that look familiar? What is that in French? I didn't quite hear that, but it's awesome, maybe. I think people love or hate durian, right? But we can switch the version that quickly, and you can roll back to a previous version. Like if we want to go back to cherry, because I was wrong about how popular it is, we can revert back to a previous version very easily. And we can also kind of split the traffic, where we say we're going to do 80% apple and 22% durian, or whatever we'd like to do. So that's a fun thing you can do because you've got the hosted environment. OK, so App Engine lets your developers focus on code, and we handle all the rest that you need to do. So that's awesome. And if you add in the flexible runtimes, that means you can run any Docker image, and you can also take that image and run it other places. So the same code that you've made to run in App Engine, you can run in Container Engine or on virtual machines or on your other, on your own machines, actually. And even though this is fully managed, you can actually still SSH in and do debugging and things if you need to via Flex. And just for fun, App Engine is used a lot. 100 billion requests per day on average last time we updated the numbers. So next up, we're going to keep going. Cloud Functions. So this is internet glue, I'm going to say. And I think you can use it in lots of different ways. But I think one of the most powerful, kind of easiest places to start is for things that are event-driven. Something happens, you want to do some processing, do something else. So event, process. And just think of it as like it just starts a function call. So the events we can trigger off of are pub/sub, cloud storage, and a straight HTTP request. And this isn't actually the topic of the talk, but if you're using Google Cloud, I highly recommend looking into pub/sub and cloud storage. They're kind of like the glue between all the different parts that you might, between the blue hexagons. Almost every application uses cloud storage and pub/sub in some fashion. It's very, very useful. So please check them out. Cloud Functions is fully managed. You have the function definition, and you just push that, and we run it for you. And you only pay per execution. It is an open kind of format. We have a Node.js runtime that you can run on your own machines, or you can have hosted in Cloud Functions. So you can do local testing and run it in other places. So when you're using it, you're thinking about events and the function definition. And that's kind of it. It's a good fit when you want to be like serverless up front. If you're already using pub/sub or storage, you don't want to think about the runtime environment very much. And it's basically this glue. Constraints-wise, I'll very carefully say there is one runtime today. And we're looking, and that's Node.js, so JavaScript on Node.js. Looking at other languages. And it forces you to think per function. And sometimes that's a real advantage. And sometimes that can get complicated if you have lots of functions. So kind of be careful there. And demo is less of a demo, more kind of just what this looks like. This is the Cloud Functions kind of overview here. Let me actually go back. So this is a list of different functions I have deployed. I've got a hello world function that, as you might expect, doesn't do very much. It has an HTTP URL that we can use to trigger it. So if I click on that, it will run it and do whatever the function does. We gave it no parameters. And this function, if you give it no parameters, just says no message. I don't know what to do with that. So what does this function look like? We can come and look at the source here. And we'll find out that if there's no body, it just returns this message we just saw. And if there is something, it will actually log that and return. So it's kind of like an echo hello world app. So if I grab this, we can actually come over here. So you can do testing via HTTP any way you like. But there's also kind of a built-in, let's just try this out, tab. So we can say, hello, Paris. Click test the function. It will make that call. We actually get a success back. And that's what it looks like. So there isn't that much to see in functions. But basically, you take some input. You can do some work, have a side effect or not, and then return some information back at the end. So this is just a function that lives in the cloud. And you can use it to connect different pieces. It's integrated with our logging system, centralized logging, so you can look at it here, but you can also look at it in Stackdriver logging, see what's happening with them, that sort of thing. OK. So you think about functions. You don't have to think about servers. You just pay for what you use. Simple developer experience. OK, seriously, where should I run my code? Did you find a good fit already? So as I was talking through things, did Compute Engine or Container Engine jump out? If so, go take a look at that. Research that, play with that, see what it looks like. Probably, though, it depends a little bit. So here's a few more things that you might consider, in addition to just what these tools are. The level of abstraction that it gives you, the technical requirements of your application, and the team that you have, your company, the people you work with, what those look like. So for example, for abstraction, what happens is, like, what level do you want to be thinking at? So if you have people that are more developer kind of like mindset, you might want to spend more time thinking about code. If you have a really established operations group, you may be already wanting to think about containers or down into Compute Engine. So abstraction level. Technical requirements. So if you have specific needs, if you need a custom kernel to make your application run, you're probably going to be looking at VMs down at Compute Engine. And so technical constraints will kind of push you down the abstraction stack. Something that happens there. And then your team. How do they think about software? How comfortable are they with containers, for example? How much existing code do you have that you need to make sure it works? And do you have processes that need to work a very specific way in your company? And you may need more flexibility to implement those. That may kind of push you down into the details a bit sometimes. OK, so all these different things. How do you make the right decision? I'm gonna claim no worries. It's actually very easy to switch between these levels. If you're in containers, so that's the kind of if there. So if your application can run in a Docker container, then awesome. And if you start at the App Engine level, so if you're starting a new project and you start at a very high level of abstraction, if you want to move down, it's a change one config line, and you go from App Engine Standard to Flex. Once you're in Flex, it creates a Docker image every time you deploy. So you can take that same Docker image, and you can run that in Container Engine, or you can run that in Compute Engine. So you can take the exact same code and run it in all of these environments already. If you're starting at Compute Engine and you need to go up, like you may have to, there's some work involved in getting it into containers. And then you can do the same thing. You can kind of move up the stack and decide where you want to run it. Also, most systems that are mature, they end up using multiple parts of things. You might have an App Engine front end for your web API and some kind of long-running processes. Maybe do transcoding, video transcoding, or some other work in VMs. So it's very common to have a system that's made up of using these together. OK, so back to the very beginning. If you've got an event-driven problem, start at Cloud Functions. If you are starting a new thing, you know you're going to be on the web, start with App Engine. If you're all in on containers, Kubernetes, Container Engine. And if you have an existing system, you should probably start looking at Compute Engine. And that is the core of that. And I would like to hand over to Ellie. Actually, and this clicker for you. Thank you. Thank you.
Bonjour à tous. As you could understand, I could have done this presentation in French, but I want Brian to understand it, so I will do it in English as well. So my name is Elie Melois. I am one of the co-founders and CTO of Lumapps, and I'm really glad to be here today to tell you more about our journey using Google Cloud Platform. It's been more than 5 years now. So first, what is Lumapps? So Lumapps is the only corporate and social portal recommended by Google, and it's fully integrated with Google G Suite. So it's basically everything you need to work in one place. And our goal is to make sure that you will never need your old intranet again. So Lumapps is a social, mobile, and smart intranet to connect and engage employees. It brings all your internal communication in just a central hub. So corporate news, business applications, including G Suite, and social collaboration. It's built on top of G Suite, and it integrates with the directory, with groups, with Drive, with Gmail, with Calendar, with Sites, and much more. And we are really proud at Lumapps to have a team 100% dedicated to the Google Cloud Platform. And being a recommended Google partner means that we work, Google and Lumapps, together to align all the product roadmaps. And as you can see, our solution has been adopted already by major G Suite customers. So for instance, Colgate, Logitech, and Auchan have recently joined the Lumapps family. So just to give you a bit more information about our story. So we created the company in 2012. So at the beginning, it was just 3 guys. We were not in a garage, because in France, people work in an office, and we started at a time when the Google Cloud Platform did not even exist. So at that time, it was called App Engine, and it was a very, very new product. But when we started, we didn't have the necessary financial resources, nor the time, nor the people to rely on our own infrastructure. And we just wanted to build our product. And that's why we chose App Engine, which was at the time the only fully managed platform available. So we started the company with a Java stack, but we quickly moved to Python because we love the simplicity of using it. And we really like Google technologies at Lumapps, so we adopted AngularJS at the same time, and we built an open source framework which is called Lumapps. It's like material design for AngularJS. It's open source, so you should check it out. And since then, more and more companies have been using our product. Our team has been growing. Our App Engine invoice also has been growing bigger month after month, but that's good news. And when Google recommended us at the end of last year, or when a big customer like Valeo with 50,000 employees went live, we should have been scared. Will it work? Will the platform run under such a load? The answer is yes. And we had like the most boring go live ever. So we were just in front of our computers, looking at the platform going to explode, and no, it just works. And you can go live on a huge number of people, and the platform will work. So as you can see, we've been relying on almost only the standard App Engine from the beginning, and we've been adding some pieces along the way. So our backend is in Python, and we use all the niceties from Google App Engine. So we use the cache system, we use the native integration with Cloud Data Store, which is a NoSQL database, and we use the queuing system, to handle a large tasks that you want to run in the background. We also use Cloud Endpoints, which is a framework to build some API. So you have all the OAuth2 authentication built in. It's the same technology that runs the API on all the Google products, so Drive, Gmail, Calendar, and so on. And it's used by all our clients through the web, Android, iOS, and all our customers who are doing some custom integration using the API. So my diagram here is not totally accurate because we have some pieces running outside of App Engine. So for instance, we have a small cluster of Elasticsearch. I will explain after why we have this. And we also have some machine learning pieces which are running on Compute Engine. And with this, we can interact with external services, so that can be all the Drive API, Calendar API, Gmail API, as well as other third parties. We also plan on integrating with Firebase for real-time notification and interactions in the product. So you can do pretty much everything with App Engine, but sometimes when you use it, you will hit like a roadblock, and you have to ask this question: should I move away from App Engine? Should I go down the stack to Container Engine or Compute Engine? Well, this happened to us at various occasions, and we always had to come up with like a pragmatic solution to handle these situations. So let me tell you the story of our search engine, for instance. So it's built on top of the App Engine Search API and some third parties API. So the App Engine Search API is really great. It allows you to index documents and do complex queries at scale. It's fully managed. And don't get me wrong, it just worked. So for us, it was like the perfect search system. So we started using it in production back in 2012. And at this time, it was like an alpha product. So it was very, very new. But it has always worked for us, except when you do some very complex queries, which exceed 2,000 bytes. And when you do that, it just doesn't work. And so this is the limit. But we needed more because we have some very complex queries to run. But this is a very small fraction of our queries. So the question was, should we remove the search API for those queries? And the answer was no. We will just create a small Elasticsearch cluster and index the documents twice. And for the small fraction of queries that do not work with the search API, we will use the Elasticsearch cluster instead. And this cluster runs on Compute Engine. And it's the same with the API. So the Cloud Endpoints framework is really great to expose your API and have a way for people to interact with it online. But it doesn't come with a good documentation system yet. So we had to hack our way into creating such a portal. But as the framework for Cloud Endpoint is open source, we were able to just create this portal using these open source libraries. And so just a few tips if you want to be using App Engine efficiently. The first thing is that you should read the manual. There are some very good stuff in the documentation from Google. Especially the English version, which is more up to date. You shouldn't be afraid to use services that are relatively new because they work. So we used some service in alpha mode, and it was just OK. You should subscribe to the mailing list from App Engine because there is some really good stuff here, and you can get some good information. And the last point is not obvious, but you should pay for support because sometimes when you are in production, you will have some issues, and you want the support team to give you some answers very quickly. So everything is great with App Engine, but we have a few challenges today. So the first one is about measuring and debugging. So App Engine comes with Stackdriver, which are a lot of features to do some logging, some analytics on the code, some debugging. So it's really great. It's really good to have access to all the logging system and to be able to search inside the logs. But sometimes you need more. You need to have an agent installed on the machine, and you can't do this with standard. So for instance, if you want to use a tool like New Relic or Datadog, you won't be able to do it with Google App Engine Standard, and you will have to move to Flex. Then we have some, I wouldn't say issues, but sometimes it can be tricky to have your application working in some countries, especially in China, where App Engine is not like the best tool over in these countries. You have some quotas also. So for instance, if you intend to run, to send a very large number of emails, you will be limited on App Engine because they want to prevent, spam and so on. So keep in mind those quotas, and if you need more, you should consider using an external service instead. For the database, so you have Cloud Data Store, which is really a good tool, but you need to know how to use it, because if you use it as a SQL database, it will just not work. So keep in mind that it's designed for scale, and that there is some trade-off when you design your data model. And if you do that, you can really have something which will scale with no limit. And the last point is about moving from standard to flex. So as Brian was saying, if you want to move from one to another, you need to really decouple the services that you are using, because natively on standard you can use the cache system, the queue system, and if you and the data store, and you cannot do this directly using the same libraries on Flex. So there are some trade-off on how you can move from one to the other. And finally, let's talk about the new stuff that we are working on. So the first one is Cloud Spanner, and this one is really exciting. It offers the scalability of a managed database, but with the flexibility of SQL. So we will implement it for complex objects with relationships, where the Cloud Data Store is maybe too limited for this. It's not the right tool. We also want to implement a multi-region infrastructure, because we have instances in multiple regions in App Engine, and natively there is no load balancer on top of all these regions. You have to do it on your own, and so we are looking at the best way to aggregate all of the instances under the same infrastructure. And finally, so our dream at Lumapps is to build a personal assistant for employees, and to be proactive, to serve the right information to the right people at the right time. And to do that, we've started implementing machine learning algorithms, and we want to intensify the usage and build on top of Cloud ML to scale our models and refine our data. And so finally, when I prepared for this presentation, Brian asked me a question. He said, if you had to make the decision today, would you make the same decision? And the answer is yes. App Engine has been really helpful along the way. And frankly, I'm not sure I would be here today if we had not made this choice 5 years ago. So today we serve 1.5 million users with only one person doing some DevOps in the team. So it's, we were able to really focus on building the product, which is great. What we could have done better is the decoupling between standard App Engine features to make sure that it's easy to switch from one system to another, so from standard to Flex to Container Engine and to Compute Engine. That's all. Thank you.